I have two functions here, and I am trying to determine, using composition, whether or not they are inverses of each other. Composition means that one function is being put into the other. Inverse means that the functions would undo each other. My first success criteria tells me that I need to check if I put one function into the other, does it equal x? I also need to check doing it the other way. So in this case, if I put h into g, does this one also equal x? Both of these need to work in order for it to actually be inverses. My next success criteria is where I actually do the composition. My instructions here, this h of g of x, tell me that I am taking function h and putting function g into it. I know that function g is 3x minus 2. So what I'm going to do is rewrite function h, but instead of writing x, I'm going to leave a blank for now. So I have negative x plus 2 over 3. And then that blank gets filled in with the 3x minus 2. Notice that I put that in parentheses. That does matter. Okay. Success criteria 3 tells me just to simplify that. I don't have to do anything there with the left side because that was just the instructions telling me what to put into which function. But on the right here, the first thing I want to do when I'm simplifying, if possible, is distribute. In this case, all that I'm distributing is that negative sign, which gives me negative 3x plus 2 plus 2 over 3. I'm going to continue simplifying, showing every step of my simplification. This division bar acts like parentheses, so I have to do everything on top before I can do any of the division. I notice that 2 plus 2 can be simplified, giving me negative 3x plus 4 over 3. There's nothing left on top that I can simplify, so now I actually do the division. Note that because of the plus sign on top of this division, I have to divide both negative 3x by 3 and the 4 by 3. Negative 3x divided by 3 is negative x. 4 divided by 3 I can just leave as 4/3. There's nothing left here that can be simplified. So in this case, success criteria number 3 is completed. And I have noticed that no, that did not end up equaling x. I could stop here and tell you that no, they are not inverses because one of them did not work. Both have to work for them to be inverses. For the sake of practice, though, I'm going to go ahead and compose the other half of this problem. So this time I have function g, and I'm putting the h of x into it. So I'm putting negative x plus 2 over 3 into g. So I'll rewrite function g, leaving a space for the x, and then put this negative x plus 2 over 3 into that space. And now I can simplify. Again, I'm going to distribute. Be careful that you're not distributing to the top and bottom, only the top. So now I have negative 3x plus 6 over 3 minus 2. There's nothing left on top of the division that I can simplify, so I'll divide, giving me negative x plus 2 minus 2. The plus 2 and minus 2 end up canceling each other out, leaving me at negative x. Be careful with this one, because had I simplified that and accidentally forgotten about the negative, it would look like this one worked. But in reality, neither version, neither this one or this one, actually worked. And therefore, my success criteria number 4 would be to answer no.